Hello students, now question number 63. So it's saying that which one of the following alcohols reacts instantaneously with Lucas reagent, right? Which one of the following alcohols reacts instantaneously with Lucas reagent? Now, so the key concept here is the key concept, reactivity of alcohols, reactivity of alcohols with Lucas test, Lucas reagent. This is the case. Right? Now we'll see how we can able to understand this one. So the reagent will take in this case, Lucas reagent is concentrated hydrochloric acid plus anhydrous ZnCl2. ZnCl2. So here ZnCl2 will be acting as a Lewis acid. Okay. Now, so this is a reagent that we are be used in the preparation reactivity of alcohols with the Lucas reagent. Okay. Anhydrous ZnCl2 concentrated HCl. Now we'll see how the reaction proceed. First, what happen? In this case, reactivity order, reactivity order, what will happen in this case? If you take primary alcohols, let us take like this CH3, CH2, OH. So when you take in this Lucas reagent, right, concentrated HCl, ZnCl2 if you take, so here CH3, CH2, Cl, turbidity will form. Turbidity will form less reactivity. It will take around half an hour to form the turbidity. Right? It will take at least half an hour to form the turbidity. That we are calling as a glucose first primary alcohol. Now, if I take secondary alcohol, CH3, CH2, CH3, OH. This is secondary alcohol. If you take glucose reagent with this concentrated HCl and ZnCl2, if you take, here also kind of cloudiness will come, but it will take only 5 minutes of time. 5 minutes of time. If I take tertiary alcohol, so CH3, 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 and OH. So here concentrated HCl, ZnCl2. Here the product will come like this CH3, 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 Cl. Here turbidity will come immediately. Turbidity will come immediately in this case. Turbidity immediately it will form. Immediately the turbidity will be formed. Why it is depends on here carbocation. Here one more point also. The reaction mechanism involved in this case is suppose with a primary alcohol, no SN2 reaction takes place. Here SN1 reaction takes place. Here also SN1 reaction takes place. Right? SN2 reaction, there is no formation of carbocation, no stabilization takes place carbocation, only transition state will form. But when the reaction goes by the case of secondary tertiary, we have to see the stability of carbocation. So where the more stable, so reactivity we can also design like this. Reactivity is proportional to the stability of carbocation. Stability of the carbocation. More stable carbocation, faster is the reaction. That means tertiary alcohol is more faster than secondary than primary. So you can keep it as a tertiary ROOH is more faster than secondary ROH. Then we have so primary alcohol in this. So this is the rate of reactivity of Lucas reagent for the case. Okay, now in this case, what we are adding is, so let us see the question instantaneously. So this reaction, this alcohol is primary degree alcohol. Why? This hydroxyl group attached to the primary carbon. This is tertiary degree alcohol. And this again primary alcohol. This again tertiary. So in this case, most fast reactivity is second option is the correct answer. Okay.